Okay, here we have an equation, and we're going to identify the independent and dependent variables. Now, we have been looking at story problems and identifying the independent and dependent variables and talking about what type of relationship, whether it was a direct relationship or an inverse relationship. But now all we have are equations. But our definitions are still true. Our independent variable is going to be a value that has an effect on the dependent variable. And as long as we keep our definitions straight, we'll be able to identify which of the terms in this equation, which of the terms is the independent and which is the dependent variable. Alright, so m divided by 4 is equal to k. Now, I know right now that this quotient k is going to be the dependent variable because it depends on what m is. If m is 4, and I'll go ahead and plug 4 in for m, then 4 divided by 4 is going to be 1. So k would be 1. So depending on what the value of m is, that affects what k is going to be. So I would say our independent variable here is going to be m, and our dependent variable is going to be the quotient k. So I'm going to go ahead and fix that up like that. Now, let's say the value of m is 8. If the value of m is 8, and I divide 8 by 4, then the value of k, the quotient, is going to be 2. And if the value of m is 12, we can divide 12 by 4, and k is going to be 3. So in this instance, I was able to create this model here, this table. I was able to create a math model which goes along with thinking like a mathematician number 4. And I was able to illustrate or demonstrate what it looks like, how m is the independent variable and how k is the dependent variable. Now, one of the things I want to point out, while we're talking about a relationship here, this certainly is a direct relationship. I mean, it is a direct relationship. Anytime m goes up in value, the value of k also goes up. So this is a direct relationship. And once again, the math practice that I would associate with this would be number 4, made a math model. But I kind of touched on number 3 also. I used what I know about those definitions to help me. And I would also say maybe number 8, does that be precise? No, number 6, be precise, because I was precise in the way I used my definitions to identify the dependent and independent variables. Now, students, does anybody have any questions for me? One thing I want to point out to you is I went ahead and assigned a value to m. When you make your models, it's going to be an empty table, and you're going to have to come up with your own value, in this case for m. Now, could I have, we'll say, reverse engineered? Could I have assigned a value for k and then went ahead and figured out the value for m? I could have, but it would have required more steps, because I would have had to have done an inverse operation. If I had said that this was, well, not inverse operation, I would have had to have said, like if this was, I guess the inverse operation, if this were like, if I said this was 2, then I would have to multiply 8 and 2 to figure out that this was 8. If I said this was 3, I'd have to say 3 times 4 is 12. So I'd have to use an inverse operation to figure that out. But that would be a whole lot more difficult than just going ahead and assign a value to my independent variable first. So my recommendation for my students, when you do these, come up with a value for your independent variable first, and then see what happens when you plug it in, and what effect it has on your dependent variable. That's my advice to you all. No more questions? No. All right. Thanks for watching.